Hey everyone, Krishna here. Have you ever wondered how services like Netflix, Amazon, Google manage to serve billions of customers simultaneously? One of the reasons is because they understand and master the topic of today's video, scalability. A typical cloud service contains data of some form, most likely in a database. It also consists of a server which interacts with clients and can send or receive data from the clients to the database and back and forth. The server also runs some computations on the data and returns these results to the client. A server is just a collection of services. These could be primary services, which are the ones required for your cloud service, like a proxy service, the API service, the computational service, database as a service, etc. Or it could be supporting services like monitoring, logging, backup, security, etc. In this video, we're going to primarily focus on these primary services. All services require resources to run. The simplest of these resources are CPU, memory, disk storage, and network bandwidth. For this video, let's focus primarily on CPU and memory. When you have multiple clients making multiple requests, the server starts to use more and more of these resources to process those requests. Some operations are CPU intensive, while others take up more memory, and some operations of course use both. The CPU and memory of these services are not infinite, and each server has a hard limit. However, in practice, there are alerts in place to warn operators well before we hit these limits so that we never reach these hard limits. However, if no care is taken and you allow these services to hit those hard limits, then this service can no longer process requests. A simple, straightforward solution is to just increase these limits so that the service has enough resources to keep working. This process is called vertical scaling. Vertical scaling actually has a few disadvantages. Firstly, there's a hard physical limit beyond which you cannot just scale resources infinitely. If the service fails for some reason, until a new service comes in to take its place, your customer data may not be processed, and that's usually undesirable. If the service for some reason needs an update, you have to first take down this service and replace it with the newer version of the service, and during that time also your data may not be processed. We can address some of these issues by modifying the architecture of our services. Instead of having a single service for a specific function, we can design them in such a way that multiple copies of these services can run in parallel. In different contexts, these copies are called tasks, processes, containers, or pods, and in this video, I'm going to use the generic term instance. So let's go back to the example of these two instances. In order for this to actually work, we need a special service called a proxy or a load balancer, which helps to balance the load and also to route a portion of the traffic to different of these instances. We'll cover proxies and load balancers in detail later on. For now, just note that it's a special service that helps to balance requests between these different instances. When the number of requests from clients increases, we can simply add a new instance and let the load balancer use this instance to handle all the extra traffic instead of increasing the CPU or memory of any particular instance. When the requests go back to normal, we can remove the extra instance to save costs. This technique of adding or removing instances is called horizontal scaling, and it has many distinct advantages over vertical scaling. The first is flexibility. When there's high load, we can always add instances to handle the extra load, and when the load is back to normal, we can remove these instances to save costs. A service that is horizontally scalable is also fault tolerant. What this means is that if a few instances fails for some reason, there are other instances that will still be working to be able to handle a portion or all of the traffic. In contrast to the vertical scaling approach, if this one big vertical service fails, there's no alternative to replace it. These systems can support low downtime during updates. We can add extra instances of the new version and let the load balancer balance traffic to the new and the older instances. And once we've verified that the new version works, we can remove the older instance and have the newer instance. This means that your updates go smoothly and there will be minimal downtime. At this point, I want to point out that even though I've been speaking about horizontal and vertical scaling separately, they're often employed together in most modern cloud services. Before we end, there's one final topic that I would like to introduce. Scaling can of course be done manually by a human operator by monitoring some metrics, but whenever possible, it's better to do this automatically. This can be done using a special service or a collection of services called an orchestrator. This orchestrator observes the resource usage on this server and when required scales the service automatically. This is referred to as autoscaling and is a highly coveted feature in modern cloud infrastructure. I hope you've learned something about horizontal scaling, vertical scaling, and autoscaling today. That's it for now, and I hope to see you next time. Cheers!